We're continuing to look at kinematic equations as a way to describe motion algebraically. And if you remember, the purpose of these videos is to try to derive these equations with a little bit of intuition. And what we're going to look at now is displacement. And if we remember, displacement is the area that's underneath the curve, or in this case the slope, of a velocity time graph. And so to find displacement, quite simply, we look for the area of a triangle here plus the area of this rectangle, and that will give us displacement, because the displacement here would be base times height, and that it would be velocity times time gives us displacement, and up here the triangle is 1/2 base times height. So this is the beginning equation we're going to look at right here, and this is simply geometrically expressed, and we're going to change it over into the way we're going to view this kinematically. So let's move forward. Alright, so here's our formula once again. Displacement being 1/2 base times height, which is the area of this triangle, plus base times height, which is the area of this rectangle. And so now let's put in some numbers that mean more to us kinematically. So we've done the same thing here. So what I want you to see, displacement is 1/2 the base, which the base of this is time. So we're going to substitute b for t. And so the height of our triangle, because remember this was 1/2 base times height, we're looking at a triangle. The height of this triangle is the final velocity of our object minus the initial velocity of our object. And then we have to add to that the rectangle, which was base times height. So the base again is t, and the height is this initial velocity. So all we've done is taken that first formula for the area of a triangle and the area of a rectangle and substituted the alphabetic terms that describe the quantities that we look for within kinematics. And now let's see what we can do with this formula. We're simply going to continue to rearrange it a little bit. So if we look at displacement being 1/2 t times final velocity, well, that's where this comes from. 1/2 t times the final velocity. And then it's 1/2 t times negative initial velocity. So when we multiply those two, that's where this part comes from, right there. All right, and then we've got the time times the initial velocity. So we've simply carried that down. So I don't want anyone to get lost here in the algebra that we're doing. We simply multiplied 1/2 t times the final velocity, and then we multiplied 1/2 t times negative vi, which gave us this expression. And once again, I hope you're recording all of this in your composition book sequentially and neatly so that you can follow the reasoning of what we're doing. So now I'm going to move to a fresh page, and we'll continue with this bottom part that we've come up with there. So here once again, this is the part we just finished using. And what I want you to look at now is sometimes this easily escapes folks. We've got 1/2 TVI, if we look at this whole part right here, plus TVI. And what's missing in here that's just assumed is this is 1 TVI. And so just for a moment, let's think about this. If you've got negative 1/2 plus 1, what do you end up with? What's that equivalent to? Or let's even rearrange that. So 1 minus 1/2. You go, oh, okay, so that's 1/2. So I want you to keep this little tidbit in mind as I show you the next step in this equation. So let me erase this here, and let's just move backwards a little bit here. Maybe I can do it this way. There we go. All right, so now let's move forward this equation. So 1/2 TVI plus 1 TVI gives us a positive 1/2. And that's where this positive comes from. So the displacement's 1/2 times the final velocity, and this negative turns into a positive because negative 1/2 plus 1 equals positive 1/2. And if you catch that eliminates some confusion that some people have with this step. Now let's move forward and see what we can do. We're simply going to rearrange just a little bit more. We're going to combine terms here because both of these parts here have 1/2 t in common. So the displacement is 1/2 t times the final velocity plus the initial velocity. We expanded all of this, and now we're recombining things and trying to neaten it up just a little bit. All right, and we're almost done, so bear with me. So now here we are. We have displacements 1/2 t times the final velocity plus the initial velocity. And now what we're going to do is just do a little bit of algebra and rearrange some terms here. This step looks like we've turned it on its head, but really we haven't. So I want to get this t over on the other side of the equal sign, so I have to divide both sides by t. So d divided by t will equal initial velocity plus final velocity divided by 2. Multiplying by 1/2 and dividing by 2 are the same thing. So to clear up how this happened, we divided both sides of the equation by t, and then I just combined the remaining terms over here in a little bit neater fashion. And now we're almost done, because now it's time to remember a little bit. What is this displacement divided by time? Remember that d stood for displacement, not distance. So displacement divided by time is, that's right, you remembered it correctly, it is velocity. So now we have our final equation. So average velocity equals the initial velocity plus the final velocity divided by 2. And so now this equation that seems to have come out of nowhere really hasn't come out of nowhere. What we did, just to back up and kind of review, we started with displacement, as we know, being the area of this rectangle and this triangle. And so we started with area formulas, substituted the variables that we use in kinematics of displacement, time, and velocity into the very same equation. We just followed through using some algebraic steps until we ended up with this final expression of velocity being initial velocity plus final velocity divided by 2. And I hope that was fun for you, because this is, hey, let the math go ahead and be fun. Be like Alice chasing the white rabbit down the hole and enjoy the adventure. So there you go. There's the kinematic equation number 3.